Welcome to automotive territory. Electrically powered vehicles are conquering our planet, and it is a fact. Many cities like Singapore and Hamburg have vowed to replace their public transport fleets with emission-free vehicles by 2030, and many auto manufacturers have already established roadmaps and schedules for going all-in electric. Boats and submarines are getting equipped with e-motors, and even the far-reached world like Mars is being explored by the Curiosity rover thanks to an electric powertrain. But is the sky the limit for electric motors? Apparently not. Today we would like to share with you some knowledge about the first electric planes, so that when in 50 years all the aircraft in the sky are electric, you will know how it all started. Enjoy your flight! Siemens Extra 330 LE. While Siemens is currently cooperating with many smaller companies by providing them with their batteries and electric motors, their in-house engineers do not stay idle. This year, the Extra 330 LE electric airplane set 2 new world records as the fastest e-plane under and above 2,200 pounds by flying in 2 modifications. The lighter version hit 211 mph mark, while the heavier modification hit 214 mph. Moreover, 330 LE became the first electric aircraft to ever tow a glider into the sky. This is all due to a unique electric motor with a constant output of 260 kilowatt or 349 horsepower. Even though this plane will not go into serious production, but Siemens is using it to improve its electric flying technologies that will contribute to the joint Airbus-Siemens effort to build the first all-electric airliner that can carry up to 100 passengers by 2030. eFan 2.0 and eFan X. While the majority of electric-powered aircraft emerging around the globe today are developed by startups with small budgets, eFan program is backed by the multinational aerospace giant Airbus. eFan 2.0 is a 2-seater airplane that weighs mere 1,100 pounds, but has a wingspan of 31 feet. This aircraft has 2 electric motors installed that have the combined output of 82 horsepower. The batteries allow eFan to stay in the air for 45 minutes while fully loaded, with a cruise speed of 100 miles and the top speed of 140 mph. Airbus had plans to launch mass production of eFan 2.0 in 2017. However, they chose to scrap the project due to the reason that electric propulsion technology developed so fast that the design choices made in eFan had already become outdated. So today Airbus is concentrated on designing the eFan X that hopefully will be released to the market in the nearest future. Lilium Jet. The Lilium Jet is a 1,320-pound fixed-wing 2-seater plane that is lifted in the air by 36 ducted fan engines rather than usual propellers or rotors. In the air, Lilium's wings and flaps create conventional aerodynamic lift, and flaps coupled with engines serve as steering surfaces. At this point of development, Lilium is expected to have 440 pounds payload, estimated cruising velocity of 160 to 190 mph, which is by the way a significant step up over the competition, and range of 190 miles. In 2017, the first successful test flight was conducted by the Lilium team, so this electric plane is up for a great start. Facebook Aquila. Aquila is not your typical airplane, as it was not engineered to transport passengers or payloads. Facebook's creation is an autonomous flying drone that is tasked to bring internet to the most remote areas of the world. This aircraft was designed for continuous flight up to several months long, at the altitude of 60,000 feet. Aquila's wingspan is wider than that of Boeing 737, but at the same time, its carbon fiber body weighs less than 1,000 pounds. It is moving through the air by the use of 4 propellers that are powered by electric motors that drain charge from batteries that collect the power of the sun through the solar panels on the wings. Interestingly, that for such long flight durations, Aquila has to use as little energy as possible, That is why its top speed will only be 80 miles per hour, and the average power consumption is just 5 kilowatt, which is less than 3 hair dryers. This airplane has gone through 2 successful test flights in 2017, and every time Facebook's engineers are pushing it to the new limits. So hopefully, in the nearest future, the whole fleet of these electric flying drones will be bringing the internet to 4 billion disconnected humans on Earth. Solar Impulse 2. This airplane and its pilots, Andrei Borchardt and Bertrand Piccard, are bound to make it to the history books as one of the greatest pioneers of aviation who built the first airplane powered by solar energy and flew across the world on it. The major goal in the development of Solar Impulse and consequently Solar Impulse 2 was not the creation of a concept that could be then turned into a production model. It is rather an experimental project, and the creator's main intention was to make a statement that the future of humanity is in the air, but not on board of aircraft that pollute our planet with noise and CO2, but rather on the planes that run on inexhaustible power of our sun. Solar Impulse 2 has a wingspan of 236 feet, but the weight of only 5,100 pounds, which is a little more than an average SUV. The 4 lithium-ion batteries with 41 kilowatt-hour capacity each power 4 electric motors and are charged by 17,248 solar panels. With 4 giant 13.1 feet propellers, Impulse 2 has a cruising speed of 56 miles per hour, and this allowed it to circumnavigate the globe in 558 hours and 6 minutes. E-Fusion. This airplane made its debut flight in 2016 and is considered the world's first all-electric aerobatic trainer aircraft. It was designed by the Hungary's company Magnus Aircraft, that is a subsidiary of Siemens. It can carry up to 2 persons, and the maximum takeoff weight is 1,320 pounds. This plane can serve for upset recovery training for airliner pilots that is in high demand around the world. Even though currently used for exercising only, E-Fusion has potential of being turned into a private or recreational plane with much lower running costs and unique capabilities. E-Genius. This is a veteran of electric planes that flew for the first time in 2011. It was built for the competition sponsored by NASA, Green Flight Challenge, and consequently won the second prize, losing only to Pipistrel Taurus G4. It is a 2-seater plane with a wingspan of 55 feet and 397 pounds payload. The power is produced by an electric motor with 80 horsepower output. In its current development stage, E-Genius can fly up to 250 miles with a cruising speed of 100 mph. Pipistrel Alpha Electro. This electric airplane is the greenest way to learn how to fly, and it was specifically designed for flight schools to cut down on operational costs by as much as 70%. This is the 5th generation electric plane from this company and its 2nd commercial model. Among its predecessors, we have to mention Taurus Electro, that was acknowledged as the best electric airplane in 2011 at the Green Flight Challenge competition. Since then, Pipistrel has improved on its designs, and nowadays, Alpha is a capable fixed-wing aircraft that is pulled through the air by 3-blade propeller powered by a 50 kilowatt motor. The plane can accelerate to 155 mph, and the climb speed is at 75 mph. Alpha Electro can take off with 440 pounds payload, equaling to 2 passengers, who will be able to conduct training flights for up to 60 minutes plus reserve time. Sunflyer. Many experts are convinced that electric cars are superior to ICE ones not only by the eco-friendliness standards, but also from the engineering standpoint. They're simply better machines. Same goes for electric planes. The Aero Electric Aircraft Corporation that built the Sunflyer managed to decrease the drag and improved efficiency by downsizing nose frontal area, since e-motor requires less space and no air cooling is needed. Plus, additional blade area was added. This plane comes in two modifications, 2- and 4-seater. The bigger one has 38 feet wingspan and can take off with 800 pounds payload. The output of a single motor is 130 kilowatt or 177 horsepower that allows reaching the speed of 120 knots or simply 140 miles per hour. And finally, the Sunflyer can be proud of rather impressive in its class 4 hours flight endurance at the total operating costs of $17.80 per hour, compared to $122 per hour for a conventional ICE plane of the same size. Fly Nano. Fly Nano is a 154-pound one-seat amphibious plane that does not even require a license to be operated. This aircraft is all-electric and its single 5-foot propeller is driven by a 43-horsepower motor. The charge is stored by a 1.7 kilowatt-hour battery, which is really not that much, so do not expect a long flight with this limited capacity. But short full recharge time of 1 hour should at least let you go up in the air rather quickly. With cruise speed of 80 mph, we are convinced that Fly Nano will find its fans and is destined to become a popular recreational aircraft. And some honorable mentions. NASA's X-57 Maxwell. This NASA concept was created as a part of the New Aviation Horizons initiative. It is a small plane equipped with 14 propellers, 12 smaller ones that will operate only during the liftoff, and 2 bigger ones for cruising. The expected range is around 100 miles, and the max speed is 175 mph. The first test flights are scheduled for 2018, and hopefully this project, backed by the government funding, will complete its mission. Alice. This business aircraft was presented for the first time in 2017 at the Le Bourget Aviation Show by the Israeli Aviation Aircraft Company. Their prototype is designed to carry 9 passengers to the distance of 625 miles, courtesy of a 980 kilowatt-hour battery, at the cruise speed of 276 miles per hour. The Alice uses distributed propulsion when the main propeller is located at the tail and 2 supplementary ones at the wingtips, even though it has not yet flown, but the smaller-sized Orca prototype has shown the proof of concept by successfully passing flight tests. If the company secures funding, they plan the first test flight for Alice in 2018. And in conclusion, we just wanted to say that we agree that many of these planes still have rather limited capabilities, and they're patiently waiting for the battery's density to improve and reach that 400 watt-hour per kilogram sweet spot that will allow lengthier and more dynamic flights. At the same time, in order to compensate for the lack of power storage, hybrid versions of many of these aircraft were introduced that operate way more efficiently than conventional aircraft, but at the same time stay greener and produce less noise pollution. Please note that we included in this video only fixed-wings aircraft that fit the traditional description for an airplane. But if you're interested in other all-electric vessels for air travel, check out our videos about VTOL aircraft, passenger quadcopters, and drones. Link in the description and the info card. Thanks for sticking around till the end. If you liked this video, feel free to check out our previous releases, click the subscribe button and ring that notification bell to get informed when new content comes out. Do not forget to like and leave a comment below to let us know what top list you would like to see in the next episode. May the torque be with you!